For today's lesson, let us try to reach the following objectives. Determine the solution of linear inequalities. Change linear inequalities in slope-intercept form. Graph a linear inequality and identifying the solutions in a system of linear inequality through graphs. Let us have our first lesson, which is all about determine the solution of a linear inequalities. We have different symbol of inequalities. The first one we have here less than or equal to. The next one we have greater than or equal to. We also have less than, and the last one is greater than. Let's talk about those four. When we say any number that is less than or greater than to 5, those are numbers wherein equal to 5 and less than to 5. Those are the numbers 4, 3, 2, 1, and so on. And if we are going to have a that is greater than or equal to 5, it means that it is equal to 5 and it is greater than to 5, which is 6, 7, 8, and so on. But when we say a number that is less than to 5, those are the number that is not equal to 5, but then it is less than to 5. Those are 4, 3, 2, 1, and so on. So here 5 is not included. How about if we have a number that is greater than 5? It means that given a number, it is not equal to 5 and it is greater to 5. Those are 6, 7, 8, and so on. And here, as you can see, 5 is not included. So let us have an example, 3x plus 4y minus 5 that is less than or equal to 0. Find the following ordered pairs if it is a solution of our given linear inequality. Let us have the first one, 2 and negative 3. Simply what are we going to do is we're just going to substitute the value of x and y in a given linear inequality. And it must satisfy the given inequality in order to be a solution. So let us have x that is equal to 2 and y that is equal to negative 3. So for the equation, 3x will become 3 times 2 plus 4y will become 4 times negative 3 minus 5 less than or equal to 0. And now let us simplify. 3 times 2 that is 6 plus 4 times negative 3, the answer is negative 12 minus 5 less than or equal to 0. So we have 6 plus negative 12, the answer is negative 6 minus 5 less than or equal to 0. And negative 6 minus 5, the answer is negative 11 less than or equal to 0. And in here, it is true that negative 11 is less than to 0. So therefore, we could say that 2 and negative 3 is the solution of our given linear inequality. Let us have the next one, which is 1 and 2. Let us substitute the value of x and y in a given linear inequality. We have x that is equal to 1 and y that is equal to 2. So we have 3x that will become 3 times 1 plus 4y that will become 4 times 2 minus 5 less than or equal to 0. So here we have 3 times 1 that is equivalent to 3 plus 4 times 2 that is equivalent to 8 minus 5 less than or equal to 0. 3 plus 8, the answer is 11 minus 5 less than or equal to 0. 11 minus 5, the answer is 6 less than or equal to 0. In here, we could see that it is false that 6 is less than to 0. So therefore, we could say 1 and 2 is not a solution of our given linear inequality. In a given linear inequality, 2x minus 4y plus 8 greater than to 0, if the ordered pairs 0 and 2, 3 and 2 are the solution of the given linear inequality. Pause this video and try to answer this. Now let us try to answer. Given the first ordered pair, 0 and 2, let us substitute the value of x and y, and let's see if the given inequality will be satisfied. So we have 2x that will become 2 times 0 minus 4y that will become 4 times 2 plus 8 greater than 0. So let us simplify. 2 times 0, the answer is 0, minus 4 times 2, the answer is 8, plus 8 greater than 0. So in here, 0 minus 8, the answer is negative 8, plus 8 greater than 0. Negative 8 plus 8 is equal to 0, greater than 0. And as you can see, it is false that 0 is greater than 0. So therefore, we can conclude 0 and 2, or the ordered pairs 0 and 2, is not a solution of our given linear inequality. Now, let us try the next one. 3 and 2. We have x that is equivalent to 3 and y that is equivalent to 2. Let us substitute the value. 2x will become 2 times 3 minus 4y will become 4 times 2 plus 8 greater than 0. So we have 2 times 3, the answer is 6, minus 4 times 2, the answer is 8, plus 8 greater than 0. So we have 6 minus 8 that is equivalent to negative 2 plus 8 greater than 0. Negative 2 plus 8, the answer is 6 greater than 0. And in here, it is true that 6 is greater than 0. So therefore, we can consider the ordered pairs 3 and 2 as a solution of our given linear inequality. Now, let us have our next lesson, which is all about change linear inequalities in slope-intercept form. The slope-intercept form in linear inequality have different forms, such as y less than or equal to mx plus b, y that is greater than or equal mx plus b, y that is less than to mx plus b, and y that is greater than to mx plus b. And here, m will be the slope and b will be our y-intercept. In changing the linear inequality in slope-intercept form, we have here a specific rule, which is if you multiply a negative number on both sides of the inequality, we will flip the inequality sign. Let us try this one. Suppose that we have 4x plus 2y minus 5 that is less than or equal to 0. First one, all the other terms aside from the variable y will be moved on the right side of the inequality. So we have here negative 5. In order to move negative 5 on the right side of the inequality, we're going to add negative 5 to its additive inverse. The additive inverse of negative 5 is positive 5. And if we add positive 5 on the left side, we're going to add positive 5 on the right side. So here, let us simplify. It will become negative 5 and 5 will become 0. So therefore, we have on the left side that is 4x plus 2y that is less than or equal to 0 plus 5. The answer is 5. Then after that, we're going to move 4x to the right side of the equation. So in order to do that, we're going to add 4x to its additive inverse. The additive inverse of 4x is negative 4x. So if we add negative 4x on the left side, we're going to add negative 4x on the right side. So let us simplify. 4x plus negative 4x will become 0. So therefore, we will have 2y less than or equal to negative 4x plus 5. The answer is negative 4x plus 5. After that, we're going to remove the numerical coefficient of variable y. Since we have 2y that is less than or equal to negative 4x plus 5, what are we going to do? We're going to remove the numerical value of our variable y. In order to do that, we're going to multiply the whole equation to the multiplicative inverse of our numerical value. The multiplicative inverse of 2 is equivalent to 1 half. So if we're going to multiply it to 1 half times 2y, and for our inequality sign, we're going to take the note. If you multiply a negative number on the both side of the inequality, we're going to flip the inequality sign. And since 1 half is positive, we're going to remain our inequality sign. So that is less than or equal to 1 half times negative 4x plus 1 half times 5. 1 half times 2y, we're going to cancel out 2 and it will become 1. So therefore, we'll have on the left side that is 1. Less than or equal to 1 half times negative 4x, the answer will be negative 2x, plus 1 half times 5, the answer is 5 over 2. And from here, we could have our slope-intercept form, wherein we have here the value of the slope and the value of the y-intercept, wherein m, or the slope, is equivalent to negative 2, and the y-intercept is equivalent to 5 over 2. Now, kindly try to change the linear inequality into slope-intercept form. Given the linear inequality 6x minus 5y plus 4 that is greater than 0. Pause this video and try to answer this. So if we have the given linear inequality, the first one, all the other terms aside from the variable y will be moved on the right side of the inequalities. So if we have positive 4, in order to move positive 4 on the right side of the equation, we're going to add this number into its additive inverse. So the additive inverse of positive 4 is negative 4. And if we add negative 4 on the left side, we're going to add negative 4 on the right side. And then let us try to simplify. 4 times negative 4, the answer will become 0. So therefore, we will have on the left side that is 6x minus 5y greater than 0 plus negative 4, the answer is negative 4. And we're going to move 6x on the left side of the inequality. So we have 6x. In order to move 6x, we're going to add this to its additive inverse. The additive inverse of 6x is equivalent to negative 6x. And if we add negative 6x on the left side, we're going to add negative 6x on the right side. So we have 6x plus negative 6x, the answer will become 0. So we will have negative 5y. Greater than negative 6x minus 4, the answer will be negative 6x minus 4. Then after that, we're going to remove the numerical coefficient of variable y. Since we have negative 5y that is greater than negative 6x minus 4, we're going to remove the numerical value of our variable y, which is the negative 5. In order to remove negative 5, we're going to multiply the whole equation to its multiplicative inverse. The multiplicative inverse of negative 5 is negative 1/5. And let us multiply negative 1/5 to the whole equation. So we will have negative 1/5 times negative 5y. And for the inequality sign, we're going to take the note, if you multiply a negative number on the both side of the inequality, we're going to flip the inequality sign. And since negative 1/5 is a negative number, we're going to flip the inequality sign from greater than, it will become less than. And let us continue multiplying negative 1/5 to the right side of the equation. So we will have negative 1/5 times negative 6x minus negative 1/5 times 4. So let us simplify. Negative 1/5 times negative 5y. We're going to cancel out negative 5y. And in here, negative times negative, the answer will become positive. So therefore, from the left side of the equation, it will become y. Less than negative 1/5 times negative 6x will become positive 6 over 5x plus, and negative times negative 1/5 times 4, the answer will become positive 4/5. And in here, from our slope-intercept form, we have the value of the slope, and we also have the value of our y-intercept, wherein the slope or the m is equivalent to 6 over 5, and the y-intercept that is equivalent to 4 over 5. Now, let us have the next lesson, which is all about graphing a linear inequality. So given a Cartesian plane, suppose that we have a given linear inequality wherein the inequality sign is less than or equal to. In here, we're going to use a solid line representing that the line is included as part of the solution. And since it is less than, we're going also to include the value that is below the line. But then if we have a given linear inequality wherein that is less than, and in here we're going to use broken line representing that the line is not included as part of the solution. And since it is less than, we're going to include the value that is below our given line. Now, if we have a given linear inequality wherein the inequality sign is greater than or equal to, in here we're going to use a solid line representing that the line is included as part of the solution. And since it is greater than, we're going to include also those points that is above our line. And if we have our linear inequality that has the equality sign that is greater than, we're going to use broken line representing that the line is not included to our solution. And since it is greater than, we're going to include all the points that is above the line. So let us try. If we have y that is less than or equal to 3x minus 4, and in here, our slope is 3 over 1, and a y-intercept that is equivalent to negative 4, let us try to find the coordinate of our y-intercept. And in order to find the coordinate of our y-intercept, we have always x that is equal to 0, and our y will be equal to the value of b. And in our ordered pairs x and y, we could have x that is equal to 0 and y that is equal to b, wherein b is equivalent to negative 4. So let us plot the points 0 and negative 4 on our Cartesian plane. And let us label it as 0 and negative 4. And after that, using the slope 3 over 1, we're going to use the rise over the run. In here, we're going to rise 3 times and run 1 time. So here we will have 3 rise, 1, 2, and 3, and we have 1 run. And since it is positive, we're going to run on the right side. 1. And let us mark the point. Let us mark the point and label it, wherein it will become 1 and negative 1. Now, let's take a look with our linear inequality sign. So here we have less than or equal to. So therefore, we're going to use a solid line representing that the line itself is included on our given linear inequality. And since it is less than, so we're going to include those value that is below the line. So the graph of our linear inequality will become like this. Now graph the linear inequality y that is greater than negative 3/4 x plus 3. Pause this video and try to answer this. Now let us try to answer. Given our linear inequality, we have here our slope, which is negative 3/4. We have here y-intercept that is equivalent to 3. Let us try to find the coordinate of our y-intercept. For our y-intercept, we could have our x that is always equal to 0 and the y that is equal to b. So given the ordered pair, x and y, we're going to have x that is equal to 0 and y that is equal to b, wherein b is equal to positive 3. So let us plot the point 0 and 3 on our Cartesian plane. And let us label it as 0 and 3. Then after that, using the slope negative 3 over 4, we're going to use the rise over the run. And in here, we're going to rise 3 times and we're going to run 4 times. So we have 3 rise, 1, 2, and 3. Then after that, we're going to have 4 run. And since the slope is negative, we're going to run it to the left side. So we're going to have 1, 2, 3, 4 runs. And label it. So we will have negative 4 and 6. And after that, we're going to look on our linear inequality sign. And in here, we have greater than. So here, we're going to use broken lines representing that the line is not included as part of the solution of our linear inequality. And since it is greater than, we're going to include all the points that is above the line. So the graph of our linear inequality will become like this. Now let us have our last lesson, which is all about identifying the solution in the system of linear inequality through graphs. So when we say solution of a given system of linear equation or inequality, those are the ordered pairs that is being shared by the two or more lines. For example, if we have here the two lines that intersect, the point of intersection is considered the solution of these two lines. And in here, we could say the solution is only 1. And suppose that if we have two lines that is considered parallel, there is no any shared ordered pairs. So therefore, we can consider that the solution is 0. And if we have coincident line wherein two lines are overlapping each other, and in here we could say that all the points on the line are being shared by these two lines. So here we could say the solution would be infinite. So let us try this on a given linear inequality. So suppose that we have two inequalities, y that is greater than or equal to 2/3 x minus 2, and y that is less than or equal to negative 3/5 x plus 4. Let us try to find out the solution of these two inequality in a given Cartesian plane, in a given graph. So first one, let us try to graph the first equation. So here, since it is greater than or equal to, we're going to use solid line and those line that is above, and since it is greater than, we're going to include all the points that is above the line. For the second equation, we could have here less than or equal to, and since and in here we're going to use solid line. Then after that, we're going also to include those points that is below the line. So in here, all the points that being shared by these two inequalities are the solution for these both linear inequalities. And now let us try to identify the solution of the linear inequalities through a given graph. Suppose that we have linear inequalities y that is less than to 2/3 x minus 2 and y that is less than 4x plus 2. Pause this video and try to answer this. Now let us try to graph these two linear inequalities. For the first linear inequality, since it is less than, we're going to use broken line representing that the line is not included as part of the solution. And since it is less than, we're going to include those value that is less than a given broken line. It has also inequality sign that is less than. We're going to use broken line representing the line is not included as part of the solution. And since it is less than, we're going to include those points that is below the broken line. And those points that is being shared by these two linear inequality will be the solution of this linear inequality. Thank you for answering your math legend for this week. See you on the next lesson.